x squared minus 4, you can write it as x plus 2 times x minus 2. Now we need to rewrite the limit expression until we replace x with 2. Now notice that we can cancel x minus 2. So when this term is gone, we can now use direct substitution because the x minus 2 factor was given us a 0 in the denominator, which we don't want. So now all we need to do is find the limit as x approaches 2 of x plus 2. So now we can replace x with 2, and 2 plus 2 is 4. And so that's the limit. It approaches a value of 4. Now let's look at another example. What is the limit as x approaches 5 of x squared plus 2x minus 4? So notice that we don't have a fraction. We're not going to get a 0 in the denominator. So for a question like this, you can use direct substitution. So all you got to do is plug in 5. So it's going to be 5 squared plus 2 times 5 minus 4. So that's 25 plus 10 minus 4. And 25 plus 10 is 35. So the limit is going to be 31. And so that's it for that example. But now what about this one? What is the limit as x approaches 3 of x cubed minus 27 over x minus 3? Now, if we try to plug in 3, it's going to be 0 over 0, so we don't want to do that. In this case, if you have a fraction like this, see if you can factor the expression. So how can we factor x cubed minus 27? So what we have is the difference of cubes. And whenever you see that, you can use this formula. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. So in our example, a to the third is like x to the third. And b root of x cubed, which is x. And b is the cube root of 27, which is 3. So this is going to be x minus 3, and then a squared, that's x squared, and then plus ab, so that's 3 times x, and then plus b squared, or 3 squared, which is 9. So now we could cancel the factor x minus 3. So what we have left over is the limit as x approaches 3 of x squared plus 3x plus 9. So at this point, we now can use direct substitution. So it's 3 squared plus 3 times 3 plus 9, which is 9 plus 9 plus 9. Adding 9 3 times is basically multiplying 9 by 3. And so this limit is equal to 27. Now, here's another problem that you can work on. So what is the limit as x approaches 3 of 1 over x minus 1 over 3 divided by x minus 3? So for these examples, feel free to pause the video if you want to and try these problems. So in this example, we have a complex fraction. So what do you do in a situation like this? If you get a complex fraction, what I recommend is to multiply the top and the bottom by the common denominator of those two fractions. That is, by x and by 3. So I'm going to multiply the top and the bottom by 3x. So if we multiply 3x by 1 over x, the x variables will cancel. And so what we're going to have left over is simply 3. And if we multiply 3x by 1 over 3, the 3's will cancel, leaving behind x, but there's a negative sign in front of it. Now, for the terms on the bottom, I'm going to leave it in this factored form. So notice that 3 minus x and x minus 3 are very similar. If you see a situation like this, factor out a -1. If we take out a -1, the negative x will change to positive x, and positive 3 will change to -3. So notice that we can cancel the x minus 3 factor at this point. And so what we have left over is the limit as x approaches 3 of -1 over 3x. So now we can use direct substitution. So let's replace x with 3. So it's going to be 3 times 3, which is 9. So the final answer is -1 divided by 9. So now you know how to evaluate limits that are associated with complex fractions. So here's another example. What is the limit as x approaches 9 of square root x minus 3 over x minus 9? So what should we do if we're dealing with square roots? What I recommend is to multiply the top and the bottom by the conjugate of the expression that has a square root. So the conjugate of square root x minus 3 is square root x plus 3. So in the numerator, we need to FOIL. So the square root of x times the square root of x is the square root of x squared, which is simply x. And then we have the square root of x times 3. So that's going to be plus 3 square root x. And then these two will form -3 square root x. And finally, we have -3 times positive 3, which is -9. Now on the bottom, I'm not going to FOIL the two expressions. I'm going to leave it the way it is, because my goal is to get rid of the x minus 9. I want to cancel it. So now -3 and positive 3 add up to 0. So what we have left over is the limit as x approaches 9 of x minus 9 divided by x minus 9 times the square root of x plus 3. So now at this point, notice that we can cancel x minus 9. And so what we have left over is the limit as x approaches 9 of 1 over square root x plus 3. So now what we can do is replace x with 9. So I'm just going to continue up here. So it's going to be 1 over square root 9 plus 3. And the square root of 9 is 3. And 3 plus 3 is 6. So the final answer is 1 over 6. Now let's look at this example. What is the limit as x approaches 4 of the expression 1 over square root x minus 1 over 2 divided by x minus 4? So this time, we have a complex fraction with radicals. That means we need to multiply the top and the bottom not only by the common denominator, but also by the conjugate. But let's start with the common denominator. So I'm going to multiply the top and the bottom by these two. That is by 2 square root x. So when I multiply 1 over square root x times 2 square root x, the square root x terms will cancel, leaving behind positive 2. So I have the limit as x approaches 4 with a 2 on top. And if I multiply these two, the 2's will cancel, leaving behind the square root of x. And so on the bottom, I have 2 square root x times x minus 4. So now my next step is to multiply the top and the bottom by the conjugate of the radical expression. That is by 2 plus square root x. Now I'm only going to FOIL the top part, not the bottom. So we have 2 times 2, which is 4. And then we have 2 times the square root of x. And then these two, that's going to be negative 2 square root x. And negative square root x times positive square root x is going to be negative square root x squared, which is negative x. And in the denominator, don't FOIL, just rewrite what you have. If you follow these steps, it won't be that difficult. So now 2 and negative 2 adds up to 0. So what we have left over is the limit as x approaches 4 of 4 minus x divided by all the stuff that we have on the bottom. Now what we're going to do at this point is we're going to factor out a negative 1. So this is now the limit as x approaches 4. So negative 1, and this is going to change to positive x, and plus 4 is going to change to negative 4, just like we did before. So now notice that we can cancel the x plus 4 terms at this point. So this is what we have left over. So now let's replace x with 4. So it's negative 1 divided by 2 square root 4 times 2 plus square root 4. So the square root of 4 is 2. And 2 times 2, that's going to be 4. And 2 plus 2 is 4. And 4 times 4 is 16. So the final answer is negative 1 divided by 16. And so that's going to be the limit. Now let's talk about how to evaluate limits graphically.